All right, today we're going to be talking about compound and absolute value inequalities. So we're going to worry about solving one-step and multi-step inequalities. That's what we've done already, I'm sorry. And then we're going to talk about solving compound inequalities and absolute value inequalities. So we're going to first start with compound inequalities. Compound inequalities are inequalities that just have two different inequalities that we want to pair up together. Now, there are two different ways we can pair them up. We can either pair them up with and statements or statements. So this is the and statement. And when you have an and statement, x is greater than -4 and x is less than 3, we have to go ahead and talk about where they overlap or where they intersect. This graph goes off to the right. This one goes off to the left. Where is the area that they overlap in? Where's the intersection? Where are all the numbers that are greater than -4 but less than 3? That's in this section here. We do have to have a closed dot on -4 because it's a closed, and we need an open dot here on the 3 because that's an open symbol. So between those two is where we go ahead and fill in. So let's look at an and problem. What is the solution to 11 is less than or equal to 2x plus 5 and x plus 3 equals 9? Now it is two separate equations that we're going to have to go ahead and solve. So I'm going to start here with the first one, and I'm going to subtract 5 from both sides. So 11 minus 5 and 5 minus 5 here to cancel those out. So we have 6 is less than 2x, divide by 2, and 3 is less than x. Well, we would like that on the other side just to make it look a little bit nicer. So we're saying x is greater than or equal to 3. This other equation is a little bit easier. We're just subtracting 3, and we get x is less than 6. So then we want to graph where they overlap. Where are the numbers that are greater than 3 but less than 6? So there's 3, there's 6, there's the numbers in between. And again, I am following the endpoints. This is a greater than or equal to 3, so that's a closed at 3. This is a less than 6, so that's open on 6. You need to follow those rules. All right, this is a special type of and. Notice it does not say and, it doesn't say or either. Any of these that are like this, these are always and problems. There will never be an or problem like this one. Well, it might be hard to see the two different equations. So let me go ahead and split it for you. So we're going to go ahead and solve them separately. And so notice what we do. We do 10 less than or equal to 3y minus 2. So this whole middle gets used with the 10. On the other side, we have 3y minus 2 is less than 19. So notice that 3y minus 2 is used both times. Okay, so we're going to separate it like this, and then we're going to go ahead and solve each of them. So we add 2, divide by 3, divide by 3. And so we're saying the value is between 4 and 7. Greater than, less than or equal to here, and a less than there. So open and closed. So here's the two different equations, greater than or equal to 4 and less than 7. So where do they overlap? Where do both of those things occur? Well, it occurs between 4 and 7. So those are the ones that are important. Those are the ones that need to get filled in. Now let's talk about an or. An or is we use both of them. It's a union, two coming togethers. A union typically represents like a marriage or something of that nature. So we want to go ahead and combine them both together. So notice what happens here. We have a greater than 5 and a less than -3. And our answer has both of them on there. We just copy both of them down. There's really no thinking that has to really go on here. We just have to go ahead and write them both on the same graph because we're combining them. All right, this is an or because it says or. All your ors will say that. That special type of and is only an and. So let's go ahead and solve each of them. We have x plus 3 is less than 2 and negative x is less than -4. So we subtract 3 and we get less than -1. And over here we have to divide by -1, and since we're dividing by -1, we do have to flip the sign. Make sure that you do that. So x is less than negative 1 is this way. And here's the greater than 4. And again, our answer is the combination of the two. So we're going to write them both down on our answer here at the bottom. And again, we just follow the lines down and with the appropriate symbols. Let's try another one. X plus 5 is less than 1, and negative 2x is less than or equal to negative 6. So subtract 5, x is less than negative 4. That's this part of the graph here. And here we divide by negative 2. Dividing by negative still switches the signs. We have x is greater than 3, and we graph both of them, and we're done. We need to make sure that we know how to do compound inequalities, because when we go ahead to absolute value, it becomes compound inequalities. Now, you need to be careful. Any greater than symbol becomes an or, and less than symbols become an and. So here, greater than is an or, less than is an and. Now, the other thing that we need to understand is you're going to treat inequalities like absolute value equations. Remember, we went ahead and made two separate cases. We had a positive case and a negative case. We're going to need to do the same thing here. Look at this first one up here. 4x plus 5 is greater than 7, and 4x plus 5 is less than negative 7. So a positive case of 7 and a negative case of 7. Positive case of 7 and a negative case of 7. So there's going to be both of those. If you notice, however, there is an exception. Notice how a greater than on the negative case becomes less than. The negative case must switch the signs and make it negative. We have to do both now. So let's start with something really easy. Absolute value of x is less than 5. The less than does mean an and. So here's our positive case. X is less than positive 5. We didn't switch anything. The negative case is where we switch it. The less than becomes a greater than, and we have negative 5. Graphing both of those, where are we greater than negative 5 and less than 5? Obviously in between this area here. Those are the numbers that fit those answers. All right, so let's take a look at this one. This one's a greater than, so that should be an or. So we have an or here. So case 1 is greater than positive 4. Case 2, here's the 4, so it's negative 4, and we have less than or equal to. So we're going to need to solve them both. So again, positive case, negative case. Absolute value should always have both of them. There should be a separation between. So we're solving both of these. We can solve them at the same time. Plus 2 to both of them. So 2x is greater than or equal to 6, and 2x is less than or equal to negative 2. Divide. We have x is greater than or equal to 3, and less than or equal to negative 1. This is an or, so we're just going to copy both of them down. Less than negative 1 and the greater than 3. And this is our answer here. One more time, greater than does mean or. So we're going to go ahead and make a positive 1, greater than a positive 9, and then less than negative 9, our negative case. So again, we should always have these two separate lineups going. Add our 3, divide by 3, and x is greater than 4, and x is less than negative 2. Graph them both. They're both greater than and less than, so there's no filling in of the dots. And that's how we go ahead and graph each of these. That's what I have for you today.